Welcome to the first of these two videos that are going over the practice multiple choice. Feel free to skip and jump around for whatever questions you need help with or don't understand. And if you have any further questions on it, then feel free to let me know. Let's get started with number one. Number one is asking if y is x times the sine of x, then what is dy dx? So I need the derivative there, so that's going to be a product rule. So we have first times derivative of the second, derivative of sine is cosine, plus second times the derivative of the first, derivative of x is 1. And so that is your product rule. Number two, there's your function. When is f increasing? F is increasing when f prime is positive. F is increasing when f prime is positive. So let's figure out what f prime of x is. Derivative of 300x is 300 minus derivative of x cubed is 3x squared. So we basically need to make a sign chart there. So we're going to set that equal to 0. That is when x squared is 100. So that is when x equals plus or minus 10. Negative 10 to 10. So if I pick a number like to the right of 10 or to the left of 10, or sorry, to the left of negative 10, then we have something like 20 squared times 3, and this is going to outweigh and be negative. So the 3x squared is going to end up being bigger than the 300. Even when it's a negative really big, because a negative really big squared is going to be positive, and this will be still subtracted. If I plug something between negative 10 and 10, though, like 0, then I have 300 minus 0 is positive. So between negative 10 and positive 10 would be when f is increasing, because that's when f prime is positive. Number 3 is asking for your integral of secant tangent. Well, that's a derivative rule. That is straight up, do you know the derivative rule or not? And secant tangent is the derivative of secant plus c. Number 4. F prime of 1. So let's take f prime of x first. Derivative of 7x is 7. Derivative of 3 is 0. Derivative of natural log of x is 1 over x. So that is going to be f prime of 1 will be 7 plus 1 over 1, which is 7 plus 1 is 8. Moving on, number 5 is a limit question. We have the graph in front of us. Which one of the statements is false? At 2, at 3, at 4, at 5, which one doesn't exist? Basically, 2 exists. The limit doesn't equal the value of the function, but it does exist. It comes same from the left and right. 3 exists. 4 is the one that does not exist, because as I approach 4 from the left, I get down to 2. As I approach 4 from the right, I get down to 4. So the limit as x approaches 4 is the one that does not exist, because the limit from the left and the limit from the right are not the same. Six Total distance traveled from 0 to 3. Here's velocity. This is velocity, so I want the integral from 0 to 3 of the absolute value of velocity if I want total distance traveled. So I need to make sure that there's not any negative area that I should be counting as positive. 6t squared, or 6t minus t squared. Let's do a quick sign chart analysis just to make sure. Well, we're between 0 and 6, and anywhere in between there, this is going to be positive. So we really don't have any absolute value to worry about. Otherwise, we'd have to split up the integral and count the negative area and make sure we counted the negative area as positive. But in this case, we can just straight up take the integral from 0 to 3 of 6t minus t squared. Which would be 3t squared minus 1/3 t cubed. And we're doing that from 0 to 3. So plug in 3 minus plug in 0. This is going to be 27 minus 9 is 18. And then plug in 0, we get 0. So total distance traveled, usually you need to split up the integral to make sure that everything is counted as a positive area, but it's a positive area all the way across, so answer is D. Number 7 is making sure you understand the chain rule. Chain rule. Y prime, outside derivative of the inside function. So it's going to be 5 times the thing to the 4th. What is my inside function? My inside function is the x cubed minus cosine of x. Times derivative of the inside part. Derivative of x cubed minus cosine of x. Derivative of x cubed is 3x squared. Minus derivative cosine of x is negative sine of x. Which would be this one. Next is a Riemann sum question. And it's asking us to use a right Riemann sum in 3 subintervals. So RAM with 3 subintervals. That means we want to use the rightmost endpoint every time. So we have 3 as our base here from 4 to 7, times the height we want to use is the one on the right, which is 6.2, plus our distance from 7 to 12 here is 5, that would be our base, times, use the rightmost endpoint, plus our distance here is 3 from 12 to 15, and then use the rightmost endpoint, so we're choosing 5.6. So that's our Riemann sum. But then, approximation of number of liters at time t equals 15. So we also need to add in that at t equals 4, we have 50 liters. So that's going to be 50 plus this approximation. And our approximation comes out to be, let's see, 48.1 plus 16.8, that is 64.9. and add in the 50 so that we get 114.9. So we need to add in that initial condition to our Riemann sum. That's the tricky part that people miss. Number 9, what value of k will make f continuous at 2? So basically, if I want it to be continuous, the value of the function needs to match what the limit is. So limit, I want to make sure that the limit as x approaches 2 of 2x plus 1 times x minus 2 over x minus 2 should equal k. Well, that's the limit as x approaches 2. I can just cancel the x minus 2's out of the top and bottom. And then I can plug in 2. Most basic type of limit. So the value of k would end up being 5. Next, area of the region. So that means that should clue you in that we're using an integral. And if you want to draw a quick sketch of what that looks like, then you can. So here is x equals 2. We have e to the x over 2. So it's 0, that's at 1. And it's going to grow, but not quite as quickly as e to the x would. So this area right here. So that means we are just taking the integral from 0 to 2. This is just saying that 2 is the rightmost point of the integral of e to the x over 2 dx. And antiderivative there would be e to the x over 2, but that would create a 1/2 out in front, so I need to counteract the 1/2 with a 2. From 0 to 2. Plug in 2 minus plug in 0. That would make 2e to the 2 over 2 minus 2e to the 0, which is 1. So 2e minus 2. On 11, let f be the function defined by absolute value of x minus 2. You can make a table of values here. Basically what this is doing is it's taking the graph of the square root of x minus 2, which looks like this. And it's making it so that I can put negative numbers in there, get negative numbers out as well. So that's basically going to reflect it like this. And that creates, it creates a cusp here. My slope from the left is not the same as the slope from the right. So that is not differentiable, but it will be continuous. As I approach 2 from the left and from the right, my value approaches 0. The y value approaches 0 in both directions, but my slopes are not going to match. (12) is asking about u substitution. So it's telling you what u is. U is going to be the square root of x. And so let's do the little bit of extra work that we need to look at the setup. That means that du equals 1 over 2 times the square root of x dx. Right, that's x to the 1/2, so 1/2 x to the negative 1/2 is our derivative. So that means that to make it match here, I'm going to put a 2 du equals 1 over square root of x dx. So now when I take my integral, instead of dx, we're going to write a 2 du. So a 2 is going to come out in front here. And then we're going to have e to the, instead of e to the square root of x, well, square root of x is u, du. Now, the last thing is that we need to switch our bounds. So since u equals square root of x, then square root of 1 is 1, goes in the lower bound. Square root of 4 is 4, or sorry, is 2, is going to go in the upper bound. So make sure that you're also switching your bounds and figuring out your bounds from there. So that's how we get the integral there from 1 to 2. $13. What is the value of the integral from 1 to 5? You can split this and say that this is the integral from 1 to 3 of 2 dx, and then the integral from 3 to 5 of x minus 1 dx, and then evaluate out those separately, figure out what they are. The other way that I did it was I said, okay, that means when we are less than 3, then we are up at 2. And then at 3, hey, that's convenient. X minus 1, if I plug in 3, I get 2. And so the x minus 1 is going to have a slope of 1 and look like that. So if I'm wanting the area, then graph-wise, here's a rectangle from 1 to 3. And then here's a trapezoid from 3 to 5. My height here is 2. And then my bases are 2 here. And plug in 5. 5 minus 1 is 4 here. So I could take this rectangle and this trapezoid and add those two areas together. Either way, you should be getting 10. This part should be 4. This part should be 6. 14. 14 is another chain rule question. So this is a derivative here is going to be f prime of g of x times g prime of x. So what I'm going to do is I'm just going to figure out these derivatives separately very quickly. F prime of x is 1 over 2 times the square root of x squared minus 4. But then since I have an x squared minus 4 in the square root, we're going to need a chain rule. Times our derivative of x squared minus 4 is 2x. So the 2's cancel, and I wind up with x over x squared of x squared minus 4. And then my g prime of x is just derivative of 3x is 3. All right. So I want f prime of g of 3 times g prime of 3. That equals f prime of g of 3. So g of 3, 3 times 3 was 9 minus 2 is 7. So I want f prime, I want f prime of 7. Times g prime of 3. Well, g prime is just 3, regardless. So f prime of 7, that's going to be, f prime of 7 will be 7 over the square root of 7 squared minus 4, which equals 7 over the square root. 49 minus 4 is 45. 7 over root 45 times 3, which equals, well, square root of 45 can be rewritten, square root of 9 times square root of 5, as 3 square root of 5. And then 3's cancel, and we wind up with 7 over square root of 5. So that's a complicated chain rule question. And I would say that that one is an example of one where I don't think the calculus is the hard part of that question. I think it's working through the algebra and getting everything simplified. H of x is the integral from 0 to x of f of t. Well, that means that h prime of x is f of x, and h double prime of x is f prime of x. So we're looking at the integral of f, the integral of f. We are looking at f at 6. So integral from 0 to 6. We are looking at f of 6, and we are looking at f prime of 6. And it should be pretty clear which ones are larger. The integral from 0 to 6, all this area underneath here is going to count as negative. Pretty significantly negative. F of 6 is going to be 0. F prime of 6 measures my slope at 6, which is going to be positive. So from smallest to largest, we have the integral, then the function, then the derivative, which means that we have h is the smallest, then h prime, then h double prime. Ooh, here's a good question. X of t equals t minus a times t minus b. And I want to know when the particle is at rest. And so I want to know about when is velocity 0. So we need to find v of t. Since these are two things multiplied together, I'm going to go ahead and do this as a product rule. First, times derivative of the second. Derivative of t minus b is just 1. So a and b are constants, so we don't need to worry about derivatives of them. And then plus second times derivative of the first. Derivative of t minus a is also 1. So in other words, when is, I have t and t is 2t minus a minus b. When is that 0? Well, that's when a plus b equals 2t. So that's when t is a plus b over 2. Here's the graph of f, which is the integral of g. So that means that f prime of x equals g of x. And so that means that I'm wanting to know which one could be a graph of the derivative. Well, the derivative of this function should just be a constant. since my slope is always staying the same all the way across, and it should be a positive slope that is constant. So A. It's asking which one can be a graph of the derivative. And the derivative should just be a constant. 18. Oh, here's your limit definition of a derivative question. Natural log of 4, here's your f of x. So f of x equals natural log of x. And they want f prime at 4, since 4 is the point they plugged in. So f prime of x is 1 over x. So f prime of 4, plug in 4, I get 1/4. Done. No fancy limits here. As soon as you see that h approaches 0, this is actually asking a derivative question with the definition. $19. Oh, 19 is going to give me a quotient rule. This is one of the trickier ones, or more involved ones. F prime. That's a quotient rule, so that's low. D high, derivative of x is 1, minus high. D low, derivative of x plus 2 is also 1, over the square of what's below. And which points have the property that the line tangent has a slope of 1/2? So when is this 1/2? Let's see here. We have an x here and an x here that cancel, because we have x minus x. So on top, I'm just going to have 2 over x plus 2 squared. So really, I want to know, if I want the top to be 2, then I want the bottom here to be 4. So I want x plus 2 squared to end up being 4. Well, that happens when x plus 2 is 4, and that happens when x plus 2... when x plus 2 is 2, and that happens when x plus 2 is negative 2. If I take either of those and square it, I get 4. And that happens at x equals 0 and x equals negative 4. So C. $20. I'll go through it, but don't worry about this one too much because we haven't done derivatives of inverse functions. So I'm just going to do this the long way. If g is the inverse function of x, then let's just brute force it and figure out what the... There is a rule for this. There is a rule for inverse, but we didn't talk about it. So we're going to do x equals 2y plus 1 cubed. And this is to figure out what the inverse function should be. And then we're going to do the derivative. So that means y has to equal subtract 1 and then divide by 2, which is 1/2 the cube root of x minus 1/2. That is our g prime of x. Or sorry, that is our g of x. Now we want g prime. G prime of x. Derivative of cube root of x is going to be, that's x to the 1/3, so it's going to be 1/3, so 1/6, times x to the negative 2/3. So that equals 1/6 times the cube root of x squared ending up in the bottom. Now, if f of 0 is 1, then inverse functions will tell me that we're going to switch those and say that g of 1 is 0. That's what it's saying here. But otherwise, we are finding here is g prime, plug in 1, and we get 1/6. So again, there is a method and a shortcut rule for derivatives of inverse functions, but we didn't learn it. So I just brute force found the inverse function and then found the derivative. All right, 21, going across the line here. This will not have a horizontal asymptote. This is just a line, so I hope you didn't say that that has an asymptote. This has a horizontal asymptote, but it's at y equals 0. This has a horizontal asymptote because degree on top equals degree on the bottom, but it's at y equals -5, so close. Since the constant out in front is negative. Here, degree on top is the same as degree on the bottom. Y equals 20 over 4 is 5 over 1. Positive 5. So this is where our horizontal asymptote is y equals 5. (22) All right, this is asking about a maximum. And it's also asking about a maximum value. So that means at the end, I'm going to want a y coordinate. A lot of times they put the distractor answer as the x coordinate because you didn't plug back into the original function and get the y coordinate. So let's see f prime. This is another quotient rule. Low d high, derivative of natural log is 1 over x, minus high d low, derivative of x is 1, over the square of what's below. So when is this 0 or non-existent? Well, x times 1 over x is going to cancel, and I have 1 minus natural log of x over x squared. So I have x equals 0 because the bottom is 0. And then I have x equals, let's see, when is natural log of x equal to 1? Well, natural log of x is equal to 1 when x is e. Natural log of e is what is 1. I don't care about 0 because it's not in the domain anyway. Let's just check to make sure it's a maximum. Take that derivative. Anything to the left of e is going to be positive. Anything to the right of e is going to be negative because then the natural log is going to start outweighing the 1 on the top. So that is a maximum. But you'll notice e is not a choice, and that's because, don't forget, we want the maximum value, which means we want the y coordinate. So we want the y coordinate at e. That's the natural log of e over e. Natural log of e is just 1, as we talked about earlier. 1 over e. So that's figuring out your maximum and minimum. Oh, this one. Linear growth means we are growing at a constant rate. Or you can say that P will equal 200t plus C, which will result in the growth being linear. Next. For what value k does g have a critical point at x equals 2/3? So critical point means that the derivative of 0 does not exist. So let's look. G prime of x equals, this is a product rule. First, times derivative of the second. Derivative of e to the kx is going to be e to the kx. But then we need a chain rule. Times derivative of the inside part. Derivative of kx is just k. Plus second times derivative of the first. So e to the kx times derivative of x squared is 2x. So I'm going to go ahead and take an e to the kx and factor it out. And then I have kx squared plus 2x. So I want 0 to equal kx squared plus 2x. Then that is x times kx plus 2. So that's at x equals 0, and at x equals negative 2 over k. And so if I want this point, I want to become a positive 2/3, then I need the k on the bottom here to be a negative 3, so that we have negative 2 over negative 3 equaling 2/3. $25. Which of the following is a solution to the differential equation? This is just a really fancy way of doing antiderivative. Plug in the point. So antiderivative. Antiderivative of 2 sine of x. Well, that would be 2 cosine of x, but then I would need a negative. Right? Antiderivative of sine, it would be negative cosine plus c. And I want, when I plug in pi, to get out 1. So I want 1 to equal negative 2 cosine of pi plus c. And cosine of pi is going to be negative 1. So that means that I want 2 plus c to be 1. So that happens that c is negative 1. So that's what the final function is going to look like. 26. If g prime is the integral from 0 to x of e prime of t, then g double prime, since we're asking about concavity, g double prime of x is going to be even simpler, because g double prime of x is going to be just e to the negative x squared. So g prime of x, well, g prime of x is always going to be greater than 0. Why? Because this function is always above the x-axis. So its area from 0 to x is always going to be positive. G double prime of x is also going to be positive. It's going to be positive because I just said this entire graph from 0 to 2 is always above the x-axis. So we are increasing and concave up because both the first and second derivatives end up being positive. Two more, and this one's a doozy. This one's got a lot of stuff going on in it. So dy dx equals 2x minus y over x plus 2y. First off, if I divide there. And we want the second derivative at 3, 0. So let's get going with our quotient rule. Second derivative. Actually, first, before we do the second derivative, let's figure out the first derivative at 3, 0. At 3, 0, dy dx should be x is 3 and y is 0. So 2 times 3 minus 0 over 3 plus 2 times 0. So we have 2 times 3 is 6 over 3 is going to be 2. So dy dx there is 2. All right, on with our quotient rule. Low d high derivative of 2x minus y is going to be 2 minus derivative of y is dy dx. Minus high d low derivative of x plus 2y is going to be derivative of x is 1, derivative of 2y is 2, dy dx. Over the square of what's below. And so now, I'm not going to show the whole thing. If you need more details, let me know. But now I'm just going to plug in 3 for x. I'm going to plug in 0 for y. And I'm going to plug in 2 for dy dx. And figure out what that all simplifies out to be. It turns out when you work through it, that should come out to be a negative 30 over 9, which simplifies to negative 10 over 3, if you're doing it correctly. All right, one more. Last one. For t is greater than or equal to 0, we have x of t being sine of t minus cosine of t. Acceleration at the point when the velocity is first equal to 0. So first off, let's get the velocity. Derivative of sine is cosine. Derivative of cosine is negative sine, so that's going to be plus sine of t. So when is velocity first equal to 0? Well, that's going to be when cosine of t equals negative sine of t. And you can play around with that a little bit. So cosine and sine are the same at pi over 4, but cosine and the sine are the same but opposite signs first at t equals 3 pi over 4. Because in the second quadrant, sine is going to stay positive and cosine is going to be negative. So they're the same but with opposite signs first at 3 pi over 4. So now we want acceleration at 3 pi over 4. So first off, acceleration, derivative of cosine is negative sine of t plus derivative of sine is cosine of t. So I want acceleration at that 3 pi over 4. Negative sine of 3 pi over 4 is going to stay positive, root 2 over 2. Plus the cosine of 3 pi over 4. In the second quadrant, my cosine is going to be negative. So negative root 2 over 2 minus root 2 over 2 is going to be negative 2 root 2 over 2, which negative square root of 2. All right, next video you see is going to be the calculator section. Again, I'm going to go question by question through the outline of how to solve the problem. And if you need more details or have more questions, just come see me and let me know if anything still didn't make sense.